Good day, everyone. Today we will still be discussing all about the continuation on the part where I stopped for circular functions, and also let me do a recap of the first topic that I discussed, which is all about evaluating trigonometric functions using the reference triangle. So basically we did that. Kind of listen to the recap because you'll be answering some of the there will be questions on the activity that I'm going to assign you all about reference triangles. So basically what we did the last time is we make use of the reference triangles, wherein these reference triangles have a basis, which is what we have discussed the last time, all about 30, 45, and 60 theorems involving right triangles. And remember again, for 30 and 60 triangles, the angle opposite to the I mean the side opposite to the 30-degree angle is always half as long as the hypotenuse. And also for the 45-degree right triangle, or 45, 90 degree right triangle, we are able to calculate for our values there, given that the two sides are equal. So if the two sides are equal, then we'll be able to notice that the values that we are going to have are square root of 2 over 2 and square root of 2 over 2. So basically we are going to make use of that one in coming up with our reference triangle. So instead of setting up our R, which varies there in angle and standard position, we set up our R there as our R here, which is 1. So that's why in each of the reference triangles that we have right here now presented, they have radius or hypotenuse that is 1. So as you can see, we still have the same values that we calculated with for this side, which is our x value, or our length in x, or our abscissa. And then we still have the same value for our hypotenuse, for our vertical axis, which is 1/2. So as you can see, if we base it off from the theorem of 30, 60, 90, the angle opposite to the 30-degree, the side opposite to the 30-degree angle is half as long as the hypotenuse. So if this is 1, this is going to be 1/2. And also, as you can see here, for our 60, 30, 90 triangle, it's the same thing. So basically, if this is going to be 30 degrees, the side opposite the 30-degree angle is going to be half as long as the hypotenuse, so this is going to be 1/2. And of course, this is going to be calculated using our Pythagorean theorem. So as you can see, if we do that, r squared is equal to x squared plus 1 y squared, we are telling na yung r natin here is 1, and then our our y is 1/2, and then we are just going to equate this equation. So if we do that, it would be now y squared is equal to r squared x squared is equal to r squared minus y squared, which would give you x is equal to the square root of r, which is 1 minus 1/2 squared. So it would be now x is equal to the square root of 1 minus 1/4. So this would give you x is equal to the square root of 4 minus 1, which would give you square root of 3 over 4, which would give you x is equal to the square root of 3 over 2. So as you can see, we come up with the value for square root of 3 over 2 if we set up the r as 1. Same case yung kanyang concept with what we did with 30, 60, 90. As you can see, same pa din yung mga values ng angle natin. And then, we do the same thing. We apply the Pythagorean theorem as well to come up with these values involving 45, 45, 90. So if we do that, 45, 45, 90, right isosceles triangles, meaning yung two sides are equal. So for this case, it's going to be now square root of 2 over 2, square root of 2 over 2 for each of the side. And then, of course, this is always going to be 1. So anyways, so much for that. So let's try to do a recap with one of the examples here. So I did this the last time, And then I think I did this as well the last time. I did this and I did this for the last time. So let us do two more examples so that I could properly illustrate what I'm talking about in applying our theorem. I mean, in applying our methodology in calculating for the trigonometric values involving reference triangles. So as you can see here, we are evaluating sine 210 degrees. So if you do that, okay, anyways, log siya there. So let me add another page and just transfer this specific item to a new page. So yan. So we are calculating for sine 210. So how do we make use of our reference triangle? What we are going to do first is, of course, find its reference angle. So if we're going to find the reference angle of sine 210 degrees, remember that if we are trying to calculate for the reference angle, that would be the positive acute angle in terms of this angle given. So for this case, since these, if I'm going to illustrate kung saan siya na quadrant nag-stop, 210 would stop at quadrant 3. Kasi this is 180, so this is gonna be 225, so 210 is kind of right here if I'm going to estimate. So basically, the rotation is going to be from the positive side of the x-axis to that specific location. So this is theta is equal to 210 degrees. And then we are going to get the reference angle out of this one. That's step 1. You have to find the reference angle. So theta prime would be, since this is in quadrant 3, the formula that we use in order to find the value in quadrant 3 for reference angle is theta prime is equal to theta minus 180 degrees. So basically that's 210 minus 100, or 210 degrees minus 180 degrees. And 210 minus 180 is just basically 30 degrees. That means our reference angle is 30 degrees for 210. Degrees. And that specific angle is here. So basically, theta here is 30 degrees. So this is the reference angle in terms of the positive, in terms of our angle, which is an acute angle or a positive acute angle in our theta, which is our angle here. And then the next thing you need to do is step 2, which is trying to find what would be the reference triangle that we are going to use in terms of our reference angle. It's obvious naman, we are going to use the 30-degree reference triangle. So basically, if we are going to illustrate that one, that would be looking like this, yung 30. So if this is 90, this is going to be 60, this is going to be 45, this is going to be 30. So we are going to create a reference triangle. And again, the angle, side opposite to the 30-degree angle is half as long as the hypotenuse. So if we set up r as 1, this is going to be 1/2. Therefore, this is going to be square root of 3/2. And then, step 3 is to find the trigonometric value in terms of our reference angle. The reference angle. So that is theta is equal to 30 degrees, meaning we are going to find sine 30 degrees. So again, sine 30 degrees is in terms of our y value. So ano yung y value natin dito? Yung y value natin is in our vertical axis. So this is our vertical axis. This is the length of our vertical axis. So therefore, that is 1/2. So our sine 30 degrees is gonna be 1/2. And then if this is our value for our sine 30 degrees, then we are now going to find the original value in terms of our reference angle. Since we're talking about sine 210 degrees, that means our angle is in quadrant 3. And remember again, in our quadrant 3, the x and the y value there are both negative. So instead of having a 1/2, instead, our value for sine 210 degrees is going to be a negative y value. So therefore, sine 210 degrees is negative 1/2. So that would be the value ng sine 210. So basically, you just have to follow the steps. The first one is, step 1 is to find our reference angle in terms of our original angle. Step 2 is find yung ating reference triangle. And then step 3 is you are going to find the trigonometric value in terms of the reference angle, and then find the original value in terms of where the angle actually lies, which quadrant it lies, or where our terminal side would terminate na quadrant. So that's the methodology that we use in order to find the trigonometric value without using the calculator. But let's try to see kung ano talaga yung value niya if we are using the calculator. So if we use the calculator, we are going to do sine 210 degrees, right? The sine 210 is going to be this one. So sine 210 is negative 1/2. As you can see, this is negative 0.5, that is negative 1/2. So we are actually correct. So even without having the calculator, we could actually find the trigonometric values of the special angles by just using the reference triangle. And anyways, let me do another example involving that one. So let's do the other example, which is cosecant 480 degrees. Yan. This would be our angle. And again, what you are going to do as a solution is do step 1, which is finding our angle, or our reference angle, I mean. So that is theta prime would be what? So you cannot find our reference angle without drawing it first, kung saan siya nag-terminate. So as you can see, this is 480. So meaning 480 minus 360 is 120. So basically, our angle would terminate at 120. So isa siyang ikot or isang rotation but would terminate at 120. So if this is 135, this is gonna be 120, if I'm correct with that, because 90 plus 45 is 135. Yes. So 90 plus 45 is 135. So basically, kinda near doon siya sa ating 135. So dyan siya nakalocate. Let's say dyan siya nakalocate, or dyan siya nag-terminate. So meaning, if it's an angle in standard position, it would rotate from the positive side up until this terminal side. So theta here is actually 480 degrees. So isang ikot pa pala, and then it would terminate here. So that's it. So yan yung 480. But we cannot immediately find our value for the reference angle with the value 480, because there is a rule that if you are going to use a formula ng ating reference triangle, it would just be applicable from 0 to 360 na interval. So if you have a value that is more than, or you have a theta that is greater than 360 degrees, what you do is first subtract it by 360 degrees up until yung theta natin is in between 0 degrees and 360 degrees. And then if it's a theta that is less than 0 degrees as well, it's the same thing. Instead of subtracting 360 degrees, we add 360 degrees until our value becomes in between theta of greater than 0, less than 360 degrees. So For this case, this is more than na 360 degrees, so therefore we subtract 360. So what you're going to do first is find yung value by subtracting 360, which is in turn would be your coterminal angle as well of your reference angle. So if you do that, that would be 480 degrees minus 360 degrees first. So this is going to be our theta, and theta would be 120 degrees. This is not yet our reference angle. Remember, this is our coterminal. So I discussed the last time what is a coterminal angle. In coterminal angle natin is an angle that have the same terminal side with our original angle. So if yung 480 mo would rotate up until here, isang ikot at sobra ng 120 there, our coterminal angle have the same also terminal side with our original angle. As you can see, this rotation right here is actually equal to 120 degrees, where both of them have the same terminal side. So from that, we are going to find now our reference angle. So whichever it is gonna terminate for our coterminal angle, yun magiging reference angle ng ating original value. So it terminates at quadrant 2, and in quadrant 2 there is a rule that if it's gonna be in quadrant 2, yung ating formula there would be theta prime minus 180 degrees minus theta. So that would be the formula that we are going to use in order to find our reference angle. So 180 degrees minus 120 degrees is gonna be 60 degrees. So as you can see here, yung value ng ating reference angle would be 60 degrees. So saan nakalocate yung ating 60 degrees? That would be right here. So our 60 degrees, which is the reference angle, would be here, from here to there. And then, okay, we already have our reference angle. Now we could find whichever reference triangle we could base it off from our reference angle. So as you can see, this is a 60-degree angle, so therefore we are going to use a 30, 60, 90 na reference triangle. So this is gonna how it looks like, or this is going to be how it looks like. So this is gonna be 30 degrees. The side opposite to the 30 degree is gonna be half as long as the hypotenuse. So this would be our reference triangle. And then from that, step 3 is find yung ating trigonometric value in terms of the reference triangle. So we are going to get the cosecant of our 60 degrees. Cosecant of 60 degrees. And we know na yung ating cosecant is in terms of our sine, because that is a reciprocal ng ating cosecant, yung sine value. And our sine theta is actually y divided by r. So it doesn't matter kung ano yung value ng y, kasi any number that would be divided by 1 is gonna be the y values, meaning it's gonna be also our sine theta, since we set up our r as 1. So meaning sine theta is gonna be y. So if we are going to get our cosecant theta, that is gonna be the reciprocal of our y. So that is gonna be 1 over the y value. So yung 1 natin dito would be r, and then y would be this value in terms of our vertical axis. So that would be square root of 3 over 2, and then 1 times 2 over square root of 3. So that would be 2 over square root of 3, and then you rationalize it, times square root of 3 over square root of 3. So this is gonna be cancelled out, yung ating radicals. So it would be now 2 square root of 3 over 3 for our cosecant 60 degree na value. Okay? So basically that's how you find yung trigonometric values natin involving making use of reference triangle. Now we move on to circular functions. So we did discuss all about this. So again, So circular functions, instead of imagining that we are trying to measure our angle in terms of degrees, we are measuring it in terms of our arc length, which is measured in radian measure. So instead of having this theta, we replace it with our t. So in this figure, consider the unit circle with center at the origin. So, yung center of the origin natin na equation is actually x squared plus y squared is equal to 1. And remember again, in analytic geometry, we know that we could actually have these equation when we try to imagine na meron tayong conic, and then the conic section, the cone or a right circular cone would be um, dissected nung isang plane. So if I'm going to draw that, it would look like this for our right circular cone, and then we are going to imagine that we are going to dissect this portion right here with a plane. So what will happen now is that we are going to create conic sections, and one of those are circles. So basically, a special type of a conic section is a circle. And then also a special type of our conic section, of our circle or equation of a circle, is in terms of our circle. So this is the equation of a circle with center at the origin. Okay, let me properly write that down. Equation of a circle, its center at the origin. So why is it called a circle with center at the origin? Remember, yung center radius form ng ating circle or equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So, ano yung mga values na to dito, yung h saka k? Yung h saka k is actually our center. So, if we set up our center as 0, 0 here, it would be evaluated as x minus 0 squared plus y minus 0 squared is equal to r squared, which is basically just x squared plus y squared is equal to r squared, which is our figure here, which is yung ating center is always at the origin. And then, as you can see here, if we apply that formula na x squared plus y squared is equal to r squared, and we set up r as 1 here because r could vary sa ating 2D system, then x squared plus y squared is going to be equal to 1 kasi it's a unit circle. But in a context wherein we are just creating circle with a center at the origin, we could make these are we could have r that varies. So we could have r be more than 1, 2, 3, and then this circle would widen, just like this one. If we set up it as 2, no, yung r natin as 2, it could widen for our circle. As you can see, we could have a circle that looks like this. But since we are just talking about a circle with a radius 1, then that's how it gonna looks like. And then from that on, since we know that r is 1 here, we have this equation. We also know that if we want to get yung any rotation sa ating or any measure of rotation on our unit circle, we could consider either measuring it in theta, which is what we have in trigonometric function of angle, side, or position. But in circular functions, we replace it with t. So, ano yung t dito? T is not measured in degrees here, but t is a real number. Kasi yung t mo is actually a portion of your boundary of the circle or the perimeter of the circle. So, yung perimeter of the circle is calculated as c is equal to 2 pi r. Okay? So, meaning, if we do that, yung length of the boundary of the circle here is just 2 pi because we let r as 1 here. So substituting c is equal to 2 pi, meaning the perimeter of the entire circle or is equal to 2 pi. That's why the value nung ating radian measure, yung isang ikot is 2 pi radians. So if we take out a certain boundary, certain portion of the boundary lang, that is gonna be t, which is our real number here, which is called sa geometry as the arc length of the circle. So the formula for the arc length of the circle is S is equal to R theta. So if we replace yung ating S with T, that would be our arc length that we are going to measure, and then we set up of R here as 1, so it would be replaced with 1. So therefore, our T here is just equal to theta. That's why we could make use in itong context to find also the trigonometric functions of a certain measure or angle measure. So if we do that, if we relate it to our previous discussion now, since r is equal to 1, if we let p of t is equal to xy, we define the 6 circular functions of t as follows. So, number 1 is cosine t is equal to x, where x is the abscissa of the point p of t. So, you might be wondering, saan na yung ating r? Remember, your r here is set up as 1, so it doesn't matter. Any value divided by 1 is going to be the number itself. So that's why it's x. Same case for our number 2, which is sine t is equal to y, where y is the ordinate of the point p of t, which have the values x, y. And then tangent t is equal to y divided by x, where x is not equal to 0, and the other 3 are just reciprocals of the first 3. Okay? So if our cosine t is equal to x, our second t is equal to 1 divided by x. So as if kung cosecant t, yung sine t mo is equal to y, our cosecant t is just equal to 1 divided by y. And then if your tangent t is equal to y divided by x, or your cotangent t is equal to x divided by y. And all of these would be, yung denominators nila would not be equal to 0, because if it's going to be equal to 0, it's going to be undefined. Okay? So we have to set limitations wherein our denominators would not be equal to 0, because we are still talking about real numbers here. Okay? So if we apply that one, I think I have discussed all about how to come up with the values here. So for the other class, but for the other class who have not been discussed this yet, kindly listen. So using the above definitions, actually we can determine the values of the circular functions of multiples of pi and pi over 2. So how would we do that? We know na yung pi in terms of 180 degrees, in terms of degree measure is just 180 degrees. So we are just talking about the measure of the arc length from here to there, which is our pi. So what would be now the multiples of pi? Yung pi natin, yung multiple ng pi natin is also gonna be our 2 pi. So there are just two multiples of pi, there's just one multiple of pi here, which is 2 pi. So let's try to do pi, and then I will just give you yung as a task yung value for 2 pi, yung trigonometric functions for 2 pi. So let's do pi, and that would be the location here. But how do we know na it's gonna be pi? We know na it's gonna be pi because remember again, yung entire circle is 2 pi. So if we divide it by 2, yung ating measure is just the semi-circle ng ating entire circle. Okay? So that would be now the value here, since it's a unit circle, that would be negative 1, 0. So if our p of t here is negative 1, 0, that means t here is negative 1, 0. That means our sine t would be in terms of y. Therefore, our sine t, which is pi, let me replace that one, is gonna be just our y value. So that is gonna be 0. And then our cosine pi would be x, which is negative 1. And then our tangent pi is just equal to y divided by x, which would be 0 divided by negative 1, which is 0. And then the reciprocals of the first 3, so that would be cosecant pi is equal to 1 divided by y, which would give you 1 divided by 0, which is undefined. And then our second pi would be in terms of our cosine, so that would be 1 over x. The reciprocal of that is just still negative 1. And then cotangent pi is going to be x divided by y, which is negative 1 divided by 0, which is going to be undefined. So you could do the same case for our 2 pi. You just have to set up your p of t now as just 1, 0. Okay? So let's try to do naman yung ating multiples of a pi over 2. Yung multiple ng pi over 2 is just gonna be the location right here, which is 0, negative 1. But how do we know na pi over 2 siya? So let's try to imagine na yung entire circle is a pizza or a pie. So if our length of the boundary of the circle is from here to here for our pi measure, then each of the half of these measure, or the half of the arc length, would be just pi over 2. Okay, or the semicircle divided into two parts are just pi over 2 portions. So that's why each of the rotation from here to here is just pi over 2, and then the rotation from here to here is going to be pi over 2 of the entire circle. So if we do that, we could also have a pi over 2 here, which is going to be 3 pi over 2. Because if we count how many pi over 2s are there, that is 1, 2, 3. So therefore, this is 3 pi over 2. It doesn't matter naman for these cases kasi if we do that, this is just gonna be pi, which is 2 pi over 2, which is gonna be equal to pi. And if we go here, that's gonna be another pi over 2. So that is gonna be 4 pi over 2, which is 2 pi. Okay? So basically, that's it. Let's try to do yung trigonometric function value niya in terms of pi over 2. And I'll let just you do yung ating 3 pi over 2. Kasi same methodology lang naman sila. So, if we do that, p of pi over 2 is gonna be equal to 0, 1. So, meaning, our sine pi over 2 is just our y value. So, our y value here is 1. And then, your cosine pi over 2 would be in terms of your x. So, meaning, our value there would be just 0. And then our tangent pi over 2 would be in terms of y divided by x. So meaning our value is just 1 divided by 0, which is undefined. And then the other three are just reciprocal of the first three. So this is going to be now cosecant pi over 2 is going to be 1 divided by y, which is 1 divided by 1, which is 1. And then secant pi over 2 is going to be 1 divided by x, which is just 1 divided by 0, which is undefined. And then our cotangent pi over 2 is going to be just what do you call that one? X divided by y, which is 0 divided by 1, which is 0. As you can see, we could actually find the values using that one. And then also, may I remind you that if you use yung calculator and then you immediately put in pi, it would not give you the correct value kasi sometimes yung ating calculator is measured in degrees. So if you want to set up na magiging pi radian siya or radian measure, you have to set it up to radian so that it would give you the correct answer. Or either use degree, but you have to convert it, yung ating pi radian measure, into degree measure, which is kung may pi ka, you would have it in 180 degrees. Anyways, I already discussed all about conversion of our angle measures. Okay? So, yan. And then, you could do also 2 pi from there. So, let's have naman yung other, yung example. So, how would you evaluate now in terms of our pi and pi over 2 multiples? So if we do that, let's try to do 2 examples here. If you want to find sine 5 pi over 2 using the reference without using the calculator, then it would look like this, right? So each of the portion here is just pi over 2, remember. Pi over 2, pi over 2. So if you want to get the 5 pi over 2, we are going to count first dito from the first portion that we have, which is yung pi over 2 na portion ng entire pizza or the entire circle. So This is going to be 1, 2, 3, 4, 5. As you can see, we stop here. So meaning the location of our 5 pi over 2 is here. And whichever coordinates that we have right here would be our reference. So that means our x here is 0, our y is 1. So if we're talking about sine, yung sine t is just equal to y. So meaning our sine 5 pi over 2 is just equal to 1. So this is going to be 1 here. And then, if we do cosecant negative 3 over 5, that would be a starting off from this location. Kasi it moves clockwise. So, we do that. So, ilang negative 3 over, ilang pi meron sa negative 3 over 5. So, that is 1, 2, 3. That's why it stops here. So, meaning our reference or our reference point is p of negative 3 pi or equal to negative 1, 0, meaning our x here is negative 1, our y is 0. But since we're talking about cosine, our cosine t is equal to x, so meaning our x is going to be, or our cosine negative 3 pi is going to be equal to negative 1. Okay? And if we talk about cosecant negative 9 pi over 2, it's the same case of our negative 3 pi. It's moving clockwise. So we do the same thing. So how many pi over 2 are there in our negative 9 pi over 2? That's 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why it stops here, which has coordinate 0, negative 1. But then we are going to have the value na cosecant value niya, which is in terms of our sine value. So that would be 1 over y for our formula. So that would be 1 divided by negative 1, which is negative 1. So therefore, our cosecant negative 9 pi over 2 is negative 1. And our our second 6 pi would be doing the same thing yung ating first item, which is sine 5 pi over 2. This moves counterclockwise. So we start here. 1, 2, 3, 4. That will be 1, 2, 3, 4, 5, 6. So it goes back here to 6 pi, which is 1, 0. And again, our second t is in terms of our x. So second t is equal to 1 divided by x, which is 1 divided by our x value here, which is 1. So therefore, second 6 pi is just 1. Okay? So that's how you evaluate sa ating pi and pi over 2 na multiples. Anyways, I will try to stop muna recording so that magkaroon ng part 2 kasi baka mag-crash yung app. Okay?